What's up, scholars? Welcome back to Math with McKay. I am Miss McKay from Lucille Brown Middle School, and this week we are in week 6 and we're focusing on circle graphs. All right. The SOL focus for today is 6.10. The students, given a practical situation, will make observations and inferences about data represented in a circle graph and compare circle graphs with the same data represented in bar graphs, pictographs, and line plots. So our focus for today is making observations and inferences about data represented in a circle graph. Now this is picking up from where we were last week. Last week we were focusing on the same subtopic. Please make sure that you have your paper, your pencil, and your calculator so that you guys can practice as we go along. All right? Let's pause for some laughs. I know, corny, but let's do it. Here we go.
What is a computer's favorite food?
What?
Microchips.
How do you make a tissue dance?
I don't know.
Put a little boogie in it.
Where do pencils spend their vacations?
Where?
In Pennsylvania.
Why was the tomato all red?
I don't know.
It's all the salad dressing.
What?
I don't know.
All right, that was just a little pause before we go ahead and get started. I know that wasn't the funniest, but just a little humor to get you going. All right. All right, so some of the definitions that we will need to focus on are as follows. So we have circle graphs, percent, ratios, bar graphs, line plots, and pictographs. All right, so just kind of like focus on these definitions as we'll go through each of the slides and we will apply them. So at this time, I think we're going to watch a quick video on, before we get to the video, here are some percentages within a circle graph that we definitely need to focus on. Just paying attention to how each of these percentages are broken up within the graphs themselves, just to kind of give you an overview or an understanding of what it might be similar to or the equivalency of the individual pieces when broken up in certain ways. Now, it may be separated just like this, or it can be combined within different sections of a particular circle graph. So when we're dealing with a circle graph or pie graph, the total amount within the graph itself is equivalent to 100%. All right. So now if we look at each of these individual circles, they're all broken up into a portion of or a fraction of this 100%. All right. And based off of how many individual pieces the 100% is broken up to determines how much the percentages will either increase or decrease by. All right, so that's just some things to become familiar with when we're dealing with circle graphs and percentages. All right, so now here we have this particular circle graph, and we need to figure out what it's asking us or what does it tell us about this graph. All right, so you notice that each section of the graph is each section of the circle, excuse me, is completely filled in. There's no empty space. Every space is accounted for, okay? So here was a survey where they surveyed people's favorite ice cream, and these are the results. Notice there's just the colors and the key. So when you're dealing with a circle graph, they will have a key that you can refer back to tell you what's happening with the graph and what represents what. All right, so this particular graph tells us the title of the graph is favorite ice cream. It also tells us that if you look at the data that was received, half of the people surveyed enjoyed mint flavored ice cream, which is this green section here. And then if you look at this grayish or black color and then this orange color here, they look pretty similar to each other. So then that's where we have this statement over here that chocolate and butter pecan ice cream are the least favorite ice cream flavors out of the people that were surveyed. All right. When you're dealing with circle graphs, a circle graph can show percentages, it can have numbers, it can have fractions, or it can have a combination of both. But it could also be blank, and you just have to figure out what the percentages are. And that goes back into the previous slide where we showed you the images of what the percentages would look like or how much it would take up, right? So here we have no percentages at all. So this section here represents, it looks like it represents about half of the graph. So you could kind of like gauge that from there. And then this kind of looks similar to a third of the graph and then kind of go from there. And then just utilize the other ones that we've kind of gone through to help when it comes to the memorization part of it. All right. So now I want you guys to watch a quick video
Hey class, and
about
welcome to the
interpreting
Reading
or
Circle
reading circle
Graphs
graphs.
tutorial. Why do I want you to know how to do this? Well, some data in the real world is shown in a circle graph. It's also known as a pie chart. So we need to be able to read it to understand. So whether it's in the newspapers or on the internet or on TV, sometimes you'll be presented information that looks like this. And so you need to be able to read it to figure it out. So I'm going to start off just with looking at benchmark fractions, just so you have an idea of what they look like. So this circle is divided into two, right? And one is shaded in, so this is a half. You probably figured that one out. This is divided into three, and one's colored in, so it's a third. This is divided into four, and one's colored in, so it's 1/4. This is divided into 1, 2, 3, 4, 5, 6, and one's colored in, so it's 1/6. And this is divided into 8, and one's colored in, so 1/8. So 1/8 looks like that. It's, I don't know if you can tell, but it's a half of what a quarter would look like. 1/6 looks like that, and it's also a half of what a third would look like, right? And if I chopped it down to the middle, it would look like a sixth there, right? A quarter, which is also half of a half, right? And a third and a half. So we're using this information and just understanding what each fraction looks like to help us answer this question. So let's get into the question. 80 students were asked the question, what is your favorite sport? The data was shown in a circle graph. What can we learn from this graph? So here's the graph right here, labeled favorite sport. And so let's try to get what we learned from this graph. So green is always color-coded, right? Sometimes there'll be patterns also inside, but in this case it's colors. So green represents hockey, purple represents lacrosse, orange is basketball, and yellow is soccer. So by taking a look here, I can kind of figure out a few things. I'm just going to slip my information in because I'm not the quickest writer with the pen. And so what I could figure out is this, that the most popular sport, I always try to find the one with the largest amount. The most popular sport is hockey, right? The green's hockey here. I also figured out, because these are the smallest areas, the least popular sports are basketball and soccer, because they're the smallest. I also can figure out that the same amount of people said basketball and soccer, because they are the same amounts. And I'm just kind of extending here. Maybe the class was in Canada. Why do I say that? Well, because hockey is very famous or very popular in Canada, and around other parts of the world, soccer is actually called football, so maybe that would be another hint too. So now that we know how to do that, sometimes we'll be asked to figure out how many students in particular answered something or said something, or how many. So we can figure this out because we know that 80 students were actually asked the question. So let's figure this out. Hockey, now we're getting back to the fractions here. Hockey, we can take a look, and it's a half. A half of the people said hockey, and this looks like a quarter, right? So 1/4 said lacrosse, and this is half of a quarter, so 1/8 said basketball, and 1/8 said soccer, right? That's supposed to be an 8. You might not be able to see that. So let's figure it out. Half of 80, right? So half, we said 1/2, and 80 students said it, so half of 80. You might be able to figure out that it's 40, but I could also do 80, take the amount, and divide it by the denominator, 2. 80 divided by 2 equals 40. Okay, so let's do the same thing. 80 students, and we're going to divide it by the denominator, 4. That's supposed to be 80, equals, so how many people said lacrosse? 80 divided by 4 is 20. Same thing. 80 students divided by 8 equals 10. And 80 students divided by 8. Sorry, the pen's not joins a lot of dots here. Equals 10. So 40 students said hockey, 20 students said lacrosse, 10 students said basketball, and 10 students said soccer. We can always double check because if we add them up, 40 plus 20 plus 10 plus 10 equals 80, and that's the amount of students. So there you go, in under 4 minutes and 2 seconds to spare, how to read circle graphs. Good luck.
All right, so as we'll go through some of the questions, not all of the denominators and numerators are going to be the same. Notice with these examples that were given, all of the numerators were 1, as opposed to some of the other examples that we'll see. So if the numerator is 1, and they give you a specific number that you can work with, then you can just simply divide that number by the denominator of whatever the fraction is equivalent to. But if not, there's a little more that you have to kind of go into in order to obtain the actual number or the amount that the question is specifically asking you. Okay. So here, for example, we have this question here where it talks about Shady Grove Summer Camp offers several activities for campers. It says here's a circle graph showing the campers' favorite activities. All right. And then within the circle graph, you see that there are the activities, which is tennis, swimming, canoeing, fishing, and crafts. And then within that, there's also the the fractions that each of them take up. Okay. So from there, we have to answer these two questions that are below. So it says, if 200 campers were surveyed, how many campers prefer tennis? So if we look at the previous example, in the previous example, his numerators were 1. So if I take this particular number or these numbers that were given to me, here we have tennis with a fraction. So we'll write tennis is equivalent to 1/5. And I always like to write out my key, as I shared with you guys in some of the previous videos that I've done. So I have tennis is equivalent to 1/5 of the total amount of people that were surveyed. And then the total amount of people that were surveyed, so total people, and I'm going to abbreviate, was equivalent to 200. So notice in the video, he said that, well, he was using fractions that had numerators that were equivalent to 1. And then with the numerator being 1, he just took the whole number that they gave us, which in our case is 200, and then divided that by the denominator. So we're going to take 200 and divide it by 5, because tennis had a denominator of 5, all right? 200 and divided by 5, and I'll go ahead and carry out the division for those of us who actually need to see it, or for us, so we can see it, okay? So the 5 goes out the house, and then the 200 goes in the house, for those of us who, need a refresher on division and things of that sort. So we check, we take the divisor and see if it'll go into each part of the dividend. So here we have 5 is our divisor. You ask yourself, can 5 go into 2? And the question is no. So we'll use 0 as our placeholder. Then we will expand this number and you'll ask yourself, how many times can 5 go into 20? 5 goes into 20 4 times. 5 times 4 is 20. And then the next question is, how many times can 5 go into 0? Of course, we bring that 0 down. How many times can 5 go into 0? 0 times. 0 minus 0. So our answer for the first question would be 40. 40 people liked tennis out of the total amount of 200. Then we go back and we do the same thing with the second question. But if you notice with the second question is asking about fishing. How many campers like fishing? In the second question, the difference between the second and the first question is that there is a different numerator. In the previous questions or the previous examples that we've seen, the numerator was 1. But for fishing, the fraction is 3/20. All right. And then we're still using the same amount of total people. Okay. And then we would go ahead and we would carry out the same steps. So we could go ahead and take the fraction and do the same thing, but then we would have to incorporate the numerator as well. We're in essence taking the numerator, taking the answer once we take the fraction and divide it and then multiply it by the numerator. All right, so what we're going to do is we're going to take 20 and we're going to divide it into 200. Okay, 20 divided by, or how many times can 20 go into 2? It can't, so you'll use 0 as your placeholder. How many times can 20 go into 20? It'll go in 1 time. And then you do 20 times 1, which is 20. And then you bring a 0 down. How many times can 20 go into 0? 0 times. In this case, we're not done because we had a numerator of 3. So we have, when we divided 20 into 200, it was 10. So now we take 10 and multiply it by 3 in order to get 30. So that's one way we can go ahead and do this. And then here's another way. The second way we would go ahead, you could go ahead and set up a ratio or proportion, all right? And we should come out with the same exact answer, all right? So here I'm going to set up the proportion. Now, the whole amount is always going to go, so here's a formula that we could use. Part divided by whole is equal to percent divided by 100, all right? So if they give you a percentage, your percentage is always going to go over 100. If they don't, if they use whole numbers, then you just have to figure out which one is the part, which one is the whole. In our case, the total amount of people, your total is your whole. So here, instead of me writing the word whole, I'm going to say 200. Not a good color. I'm going to say 200 is my whole. I don't know how many people there are, so I can put a question mark or an X. I'll use the letter X as a variable, all right, is equal to the percentage, or the part in this case is the amount of percentage in which this is equivalent to. So that is equivalent to 15% All right, so then I say 15% divided by 100. Okay, so then I would take 200 and multiply it. So 200 and multiply it by 15. And when I do that, I get 3,000. Then I'm going to divide 3,000 by 100, and I'll bring it over here. I'm going to take 3,000 and divide it by 100. All right. So now these numbers look really, really large, but what I do is, because this 100 has 2 zeros and this 3,000 has two or several zeros, then I go ahead and just cancel out the zeros. The same amount of zeros that I cancel out in my numerator is the same amount of zeros that I cancel out in my denominators. So now I'm working with smaller numbers. So then the question is, what is 30 divided by 1? 30 divided by 1 is equivalent to 30, which was the same thing that we got when we worked it out the other way. All right. So you can have those two different methods to go ahead and do the same exact thing, and your answer will come out to be exact. Okay. Now, here's an opportunity for you to go ahead and try on your own. It says the sixth graders at Kingston Middle School voted for their favorite sport. The results are in the circle graph below. So you will read the questions and you'll go ahead and you'll do the same exact thing that we just did with the last example, but here you have an opportunity to do it on your own. All right, so when you guys went ahead and worked out these problems on your own, of course, majority of the fractions that were given has a numerator of 1. So because the numerator is 1, then you can just go ahead and take 180 and divide them by the denominators. So for the first one, if we go look at the circle graph, the denominator for basketball was 2. So if you take 180 and divide it by 2, you should get 90. For the second one, if you take, if you go look at baseball, baseball was 1/4, so the denominator was 4. You take that and you divide it, and your denominator comes out to be 4. Take 180 divided by 4, and your answer comes out to be 45. And then for football, you notice that this one does not have a numerator of 1. It has a numerator of 3. So we go ahead and we kind of do it like one of the examples that we did together. You could either take 180 and divide it by 20 and then multiply by 3 in order to get 27, or you can create your proportion and figure out or solve for x, and either way you come out with the same answer. And then for the last one, golf had a numerator of 1 and a denominator of 10. So we'll take 180 and divide it by 10 to get 18, which is pretty simple, pretty straightforward. So if you guys were able to grasp that, if you understand it, then you keep going. If not, then you kind of just rewatch the videos and kind of do the practice over again. And here is the independent practice. The independent practice is similar to what we just finished going over. You'll kind of do the same thing, answer the questions based off of the the circle graph, and whatever your outcome is, you'll go from there, and then we will pick back up on tomorrow in order for you guys to get the answers, and we'll continue on with the lesson. Please remember to go check out Dreambox for about 10 to 15 minutes each day. Enjoy the rest of your day, and that is a wrap.